So here is that index. Off screen, I've gone ahead and created a compound index based on class ID and student ID. So with class ID as the prefix, we'll be using the most selective part of our query, the point or equality query. Now, generally speaking, and this won't hold for all data sets, but generally speaking, when you're building compound indexes, as you're thinking about field order in the compound index, you want to work with fields on which you're going to be doing equality queries first, putting them before range queries, as we did here. Okay, now I'm going to mix things up a little bit, and you can see here that I've actually changed the sort we want to do to use that final grade field that I introduced when we first started looking at this particular example. So let's run this query now and see what explain tells us about performance. Okay, that was fast. So we scroll up to execution stats, and look at this. Number return is exactly equal to the total keys examined and the total docs examined. Our execution time is 138 milliseconds. So let's look at the query plan here then. And here I want to call your attention to the fact that we have a sort stage. Now what that means is that we're doing an in-memory sort. And I bet you can figure out why. Because we can see from the index scan stage that we're using that new index that we created, the compound index on class ID and student ID. No mention of final grade here. So in order to sort, we're going to have to do the sort in memory. Generally speaking, it's best to avoid in-memory sorts when we can. But in order to do that, we're going to have to make a trade-off. And that is, and this is typically the trade-off you have, we're going to have to examine a few more keys than the number of documents we return in order to be able to do that sort in the database. So let me show you what I mean. So we created this index here. Well, let's think about how this works. We're creating a bunch of pairs of values, in effect, of class ID and student ID. But what we'd like to be able to do is walk the index in sort order. Okay? So in order to do that, well, we've got our most selective part of our query here, which is fine because we want to identify every single record that uses the class ID specified in the query. But then in order to be able to sort within the index, we have to be able to walk the index keys in order, which means that we're going to have that field on which we're sorting as part of a compound index, and it's going to have to go immediately after class ID. So we want to create another compound index, and in fact, this is the one that we really want if a common query pattern is this one that we're looking at, because this will very selectively identify the records that we want to look at. And then by walking the next component of the keys all the way through the index, we'll be able to pull out all of the records in the specified sort order. And what we can do along the way as we're walking through those keys is simply eliminate any that don't match the student ID range that we're looking for. Okay, so we're going to have to touch a few more index keys than will end up being in our results set. But by doing the sort in the database, we're going to save ourselves execution time. So let's create this index. It'll take a little while. Okay, and our index finished up, so let's take a look. Now there is one thing I want to tweak about this, and that is that I want to change the way we're sorting so that we're sorting in descending order. And this index we created will work just fine for that because MongoDB can walk the index in reverse order just as easily. So let's run our query. Okay, now let's take a look at what happened here. Okay, now this is going to vary depending on what else is going on in the system. But you can see that our execution time is down quite a bit. And this is because doing the sort in the database by simply walking the index keys in order is going to save us execution time. And if we look at the query plan, we can see that the winning plan does not any longer have a sort stage. And in fact, what we ended up using was the index that we just created. Okay, so why is this a better index for this query? Well, for this data set, we know that class is very selective. By specifying an individual class ID, we're eliminating easily more than 90% of the data set. In fact, it's quite a bit more than 90%. And by specifying this, we can simply walk the index keys in order to get our sorted result set. And along the way, based on the student ID component of this compound index, we can simply make this comparison to get rid of any records that don't match this range constraint. And if we take a look at the explain output one more time, we'll see that that trade-off is in fact there, that good execution time, but we are walking a few more index keys than we have documents in our result set. But in many cases, this is a trade-off that's well worth making. Okay, so this gives you some idea of how to think a little bit about structuring indexes, and we looked at compound indexes because this is where people have the most difficulty setting up their indexes. thinking about selectivity and thinking about how to get our sorts accomplished in the database gives us indexes that pretty efficiently handle our operations.